All right. So here's the idea. Given any 2 points in a coordinate plane, given any 2 points in a coordinate plane. So let's say I have this point here, and let's say I have this point here. So I have these 2 points in a coordinate plane. Notice I'm not numbering these. I'm not telling you that this is 3, 4, and that this point is 7, 8. I'm not saying anything like this. What I am going to do, though, is in general, if this is my first point, this is my first point. Now, all of you should remember these words I'm about to say. I'm going to call this x1, comma, y1. So in other words, these are subscripts. Remember subscripts. So this is, the 1 here stands for that first point. So this is the x coordinate of my first point, and this is the y coordinate of my first point. So I'm going to call it as x1, y1. X sub 1, y sub 1, subscripts. If this is a second point, using that same idea, then this is going to be x sub 2, y sub 2. And what I'm interested in is what is the distance between those 2 points? That's what I'm interested in. How do I find the distance between these 2 points? Notice from high school geometry that that is not a line. That's called a what? Segment. That's called a segment. All right, so a segment. So a segment is where you have 2 end points. Notice I use the word end point. Here's an end point, so this point at the end, and here's another end point. So a segment has how many end points? 2. You can't find the distance of a line, but you can find the distance of a segment. And then to derive it, you're going to use the idea of a right triangle and Pythagorean's theorem. Remember Pythagorean's theorem with a right triangle? But we're not going to do the derivation. If you want to, you can look at the video dealing with that. But here's the formula for the distance. So if I want to find the distance here, d for distance, then the distance is going to be the square root of, and you're going to subtract the x coordinates from each other. So you're going to say x sub 2 minus x sub 1. So you subtract the x coordinates. It does not matter the order in which you subtract them. So you could have said x1 minus x2. It does not matter. The reason is because you're going to be squaring it. And whenever you square a number, it's always going to be either positive or what? 0. Right? Positive or 0. It's never going to be what? Negative. So it doesn't matter the order in which you do it. Plus, then you're going to subtract the y coordinates from each other. So you can say y sub 2 minus y sub 1, and then you're going to square that. So there's your formula. You don't have to memorize it. I'll give you the formula. You just need to know how to use it. But the derivation comes from using Pythagorean's theorem in a right triangle, drawing a right triangle and using Pythagorean's theorem. So there's your formula. So if you were asked to, let's say I have this point here and this point here. And the coordinates of this point are negative 5 what? Can you see it from here? Negative 5, negative 2. And the coordinates of this point, can y'all see it? It's 6. 6, 5. All right. And I'm interested in the distance between these 2 points. That's what I'm interested in. All right. And so we're just going to use the distance formula. But that's the idea. In terms of finding the distance between 2 points in a plane, you're just interested in that line segment. What is the length of that segment? That's all you're interested in. Now, remember when we saw the quadratic equation using the quadratic formula? We labeled A, B, and C. You're going to do the same thing here. You're going to label your coordinates. So let's call this my first point, and this will be the second point. Doesn't matter. You can call this your first point, this your second point. Does not matter. But if I want to substitute into this formula right here, then I need to know x1, y1, and I also need to know what? x2, y2. So this is my first point, that the negative 5 is going to be denoted as what? x1. And the negative 2 will be denoted as what? y1. Then this has to be my second point then. So 6 is going to be x2, and 5 is going to be y2. And all you do now is just plug and chug. Plug and chug into this. All right, so then you're going to say distance equals, I'm going to go ahead and do it here. Distance equals the square root of, remember the formula, look at the formula, square root of, parentheses, x2 first. What's x2? 6. Subtract x1. What's x1? Negative 5. And then whatever that is, I'm going to do what to it? Square it. Plus, parentheses. So I've taken care of the x's, now I have to do the y's. The y coordinates. I have to subtract the y coordinates from each other. Y sub 2. What's y sub 2? 5. Subtract y sub 1, which is negative 2. Whatever that is, I'm going to do what? Square it. All right, so there's my plug. Now let's chug. Square root. What's 6 subtract a negative 5 the same as?
6 plus 5.
Which is 11. So 11 squared. Plus, what's 5 subtract a negative 2 the same as?
Plus 2.
5 plus 2, which is 7. 7 squared. So that's where I'm at. On your calculator, what's 11 squared? 121. What is 7 squared? 49. So the distance is the square root of what number? 1 what? 170? Okay. So this distance is the square root of 170, wherever the units are. We're just going to say units. Square root of 170. Now, on the worksheet and on my math lab, they can ask you to simplify the radical if you can. So what perfect square, if besides the number 1, goes into 170s? Use your calculator to help you. Does 4 go to 170? The next one after 4 is 9. Now, obviously, 9 will go to 170 because this is even, right? What's the next one? 10. 16. No. All right. So then you're kind of starting to exhaust all your possibilities. So if you think about it, (170) is divisible by 5, right? But 5 is not a prime number. I mean, it's not a perfect square. But let's see what we have. So 170 divided by 5 is 34. Okay, and 34 is 2 times what? 17. So using 5, 2, and 17, can I multiply any pairs to get a perfect square? No. So can I simplify the square root of 170? No. Now, usually what students will do is they'll use the perfect squares and they'll go halfway to 170. So what's half of 170? 170 divided by 2. So all you got to do is just check all the perfect squares up to 85. So we said 25. What's the next one after 25? 36. 36 will go to 170 evenly. 49. And then next one is 64. And 81, and you're done. You stop. Okay? You're not going to go beyond halfway. So the distance is the square root of 170. The directions will also say this: round to the nearest hundredth. Nearest hundredth means how many decimal places? 2. Remember, tenths, hundredths, thousandths, 10,000. Remember your place value? So hundredths place, 2 decimal places. So in your calculator, make sure you know how to use your calculator. You want to find what the square root of 170 is. So we're going to approximate this. So this is approximately equal to, so you're going to say square root 170 Press equal. What do I write now?
13.04.
13.04. So 13.04. So whatever the units are, if this is feet, then this would be 13.04 feet, approximately equal to that. All right? Okay, so that's distance formula. We do a few more, but that's distance formula. The other thing you have to be able to do, and that's going to be important when we do the circles, the other thing you need to be able to do is find the midpoint of the segment. What is midpoint? What's the idea of midpoint?
Halfway.
The point that's in the middle of that segment, right? Halfway. So it looks like, in this case, that the midpoint's somewhere around here, maybe? All right, somewhere around there. You don't want to guess at it. You want to tell me exactly what it is. Now, a midpoint is a point, right? It has an x-coordinate and it has a what? Y-coordinate. The distance is not a point. The distance is a number. But a midpoint is a point. It has an x-coordinate and it has a y-coordinate. So going back to our segment here, where we had the x1s, y1s, x2, y2, the midpoint is this right here. I'm going to label this capital M, not lowercase m, because remember, lowercase m, we usually leave it for what idea? Slope. Remember little m, slope? So the capital M, we use it for midpoint. So we're going to denote that as the midpoint. So that's going to be the midpoint. Now to find the midpoint, listen carefully. The midpoint is a point, right? X coordinates and y coordinates. To find the x coordinate, you add the x's together, and remember middle, divide by what? Middle? Divide by 2. So you can say x1 plus x2 divided by 2. You divide by 2 because of the idea of middle, halfway, right? How do I find the y coordinates then?
Y1 plus Y.
You add the y coordinates together, divide by 2. So there's your midpoint formula. You add the x's together, divide by 2, add the y's together, divide by 2. So you have two formulas, the distance formula and the midpoint formula. So let's find the midpoint now of the one we were working on. So it looks like the midpoint's somewhere in the first quadrant. So let's find the midpoint. We'll go ahead and do it here, midpoint. So the midpoint is a point. Midpoint is a point. What is x1?
-5.
Plus x2.
6.
6 divided by 2. Now your y coordinates. What's y1?
-2.
Plus y2
5.
divided by 2. Now simplify that and you're done. Leave it as a fraction though. Don't write the decimal. Just leave it as a fraction. So that first coordinate, what's -3 plus 6? I'm sorry, I said -3. I meant what? -5, I'm sorry. -5 plus 6, which is what? 1. So my x coordinate is 1/2, right? Now my y coordinate. -2 plus 5 is
3.
3, so that's going to be 3 what? Halves. So it kind of, now remember I did this, first of all, this segment's not straight because I drew it by hand. But see where I'm saying the midpoint is? It's almost there. This is 1/2, 1.5. All right, so that's what this is. So this right here is the point 1/2, comma, 3/2, or 1.5. So if you want to, you can, if you want to, write it as 1/2, comma, 1.5. It's up to you. It's no big deal. But you see, it kind of looks like it is, although it's a little off. All right. Okay, so let's look at another one. So number 2, I'm going to go ahead and actually write it out instead of doing it in a plain.
So if we've got list those, let's just say?
If you what?
Would it, if we were to list them, would it be small d equals for distance and capital
Yeah.
D equals for?
Yeah. So you would say little d, so distance equals, and here you would say midpoint equals. Okay? Capital M. All right, so the directions are usually going to say this, though. It'll say, given the following endpoints, of a segment, determine the distance and midpoint. The distance and midpoint. So find the distance of that segment and find the midpoint of that segment. All right, so let's just call it number 1. Okay, number 1, well, actually number 2, because I already did number 1. So number 2, let's suppose we had -3, -1, and 6, -7. I made that up. Before you plug in, what might be a good idea?
Because it's sad.
Label those points. X1, Y1, X2, Y2. So let's call this one, the one on the left, your first point. So -3 we're going to call X of 1, -1 we'll call Y1. 6 will be X2, -7 will be Y2. And then all you do now is just plug into your formulas. So the distance is the square root of, you subtract, remember distance you subtract, midpoint you add. Okay? Distance subtract, midpoint you add. So the distance formula says it will be the square root of x2 minus x1 squared plus, and then y2 minus y1 squared. Again, I'll give you the distance formula Wednesday. You just need to know how to use it. Okay, so I'm going to get square root of, parentheses, what's x2? 6. Subtract x1, -3, squared, plus, parentheses, y2, what's y2? Subtract, -1, squared. So that's where I'm at. So all I did was plug. Now you chug. Okay, square root of, what is 6 subtracted -3 the same as?
6 plus 3,
And what's 6 plus 3?
9,
So I'm going to square that 9. Plus, what's -7? I'm going to write it out. A -7 subtract a -1 the same as?
so -7 plus 1,
-7 plus 1. What's -7 plus 1?
-6,
-6. Okay? So that's the -6 squared. -6 squared. What is 9 squared? What is a -6 squared? 36. It should never be negative. Because when you square a number, it's always positive or 0. So that's 36. And on your calculator, what's 81 plus 36?
117,
117? Is there a perfect square besides 1 that goes to 117? No. So you can't simplify that. All right. Now, let's approximate it to the nearest hundredth.
10.2,
So to nearest hundredth on your calculator, make sure you now use your calculator. The square root of 117,
10.82,
10.82
82,
units, whatever the units may be. All right, let's find the midpoint of that segment. So remember, the midpoint's a point, so you need to make it look like a point, an x and a y. So remember, the midpoint formula says I add the x's together. So -3 plus what? 6. Divide by 2. Then I add the y's together. -1 plus what? -7 divided by 2. All right, what's -3 plus 6?
3,
So I get 3 halves for the x coordinate. What's -1 plus the -7?
-1 plus 7. So it'll be,
-8. What's -8 divided by 2? -4. So your midpoint is 3 halves, comma, -4. That's your midpoint. That's the point that's in the middle of that segment. So if you were to just very quickly, just look at this. If I were to just plot the points, so -3, -1 is in the third quadrant, and then 6, -7 is in the fourth quadrant. And I'm drawing this by hand, so it's not going to be straight. What I just found was that this point here, 1.5, comma, -4, is the point in the middle. So 1.5, -4 is right here. Okay? So that's your midpoint. 1.5, -4. So that's what you just found. Okay? All right, let's look at this. Suppose you had -7, comma, 0, and 2, -4. So -7, comma, 0, and 2, -4. And again, you want to find the distance between those 2 points, and you want to find the midpoint between those 2 numbers on that segment. Okay, so again, before you put things into the formulas, you should do what first? Label. So x1, comma, y1. Then the next one will be x2, comma, y2. All right, so distance equals the square root of parentheses. Now remember the first parentheses where you subtract the x coordinates. So it's y2. Now remember the order in which you subtract doesn't matter. So I'll do it both ways to show you that it wouldn't matter. But let's use the formula as it is. It says y2. What's y2? Subtract y1, which is 0. Whatever that is, I'm going to square. Plus. Now let's subtract. I did the y's first, but that doesn't matter. Now we're going to subtract the x's from each other. 2 subtract what? -7 squared. All right. It doesn't matter whether you do the x's first or the y's first. And the order in which you do them doesn't matter either. Okay? Does not matter. The reason is because you're squaring them anyway. That's the reason. Remember we did slope a couple of semesters ago. The way in which you do the slopes does matter. But here it doesn't because you're squaring. What is -4 subtract 0 the same as? -4. And I'm going to square that. So I get 16 at some point. Plus, what's 2 subtract -7 the same as? 9. I'm going to square that, right? What's -4 squared? And 9 squared? Okay. What's the square of, what's 16 plus 81?
97.
Besides 1, is there a perfect square that goes into 97? No. So approximate this on your calculator. What is it? 9.85. Now, I just wanted to show you that if you had changed the order of the coordinates, it wouldn't matter. So So we could have said 0 subtract a negative 4 squared. And then we could have also said negative 7 subtract 2 squared. Okay, so the order in which you subtract them doesn't matter because you're squaring. So whether it's positive or negative, when you square, it's going to end up being positive. So 0 subtract negative 4, what's that the same as? 4 squared plus negative 7 subtract 2, what is that the same as? Negative 9 squared. What is 4 squared? 16. What's the negative 9 squared? So you get the same thing, right? 16 plus 81. 16 plus 81. So it doesn't matter the order in which you subtract because you're squaring it. Okay, and then now let's do the midpoint. Number 4, midpoint. All right, so you got to put the x's first, though, because in an ordered pair, what goes first? X, and then y is your second coordinate. Now, with the distance formula, you subtracted your x coordinates from each other, and you subtracted your y coordinates from each other. And the midpoint can do what to those x coordinates? What operation? You're going to add them. So we're going to say negative 7 plus 2 divided by what? 2. Then the other will be 0 plus what?
Negative 4.
Divided by 2. So what's negative 7 plus 2?
Negative 5.
So I get negative 5 halves is my x coordinate, so negative 2.5. And then 0 plus negative 4 is a negative 4, and the negative 4 halves is just
Negative 2.
negative 2. So that's your midpoint. So if you were to plot those 2 points, look at your segment, that's the midpoint. All right, so any questions on distance and midpoint? Now that's going to be important when we do circles, some stuff with circles. All right? Okay. Now, let's